So 4.7, CPCTC. Everybody say that 5 times fast. This is
Wait,
okay. That was kind of messed up. Maybe go home and say it 5 times fast. Like practice it really well. CPC. What do you think CPCTC stands for? Triangles are. So, what is CPC used for? Look at the note. You must prove triangles are congruent before you can use CPCTC. Remember the shortcuts that we learned yesterday? Side, 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 angle, 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 side, and hypotenuse slide. That tells you that those are shortcuts for if we only know that 3 things are congruent in one triangle to another. But what about, and then you can prove that the triangles are congruent, right? But what about the other 3 parts? What if you want to prove that those are congruent? Well, after you prove the triangles are congruent using one of your shortcuts, you can use CPCTC to say that all of the other parts of the triangle are congruent. So corresponding parts of congruent triangles are congruent. But underline or circle or put box around the congruent triangles part. You must prove that the triangles are congruent before using CPCTC. So in a proof, you will say, it will get down to saying that the triangles are congruent. And then the first couple proofs we'll do, that will just be the first step that we'll be able to do. And then once you prove that they're congruent, you can prove that any other part that's not marked in the diagram is also congruent. Pretty nifty, right? So, and it's an easy theorem to prove. You know, you can imagine, well, yeah, triangles are congruent to corresponding parts. So there's nothing that we need to write here. I mean, you could make a triangle, you can make a congruent statement from 2 triangles. How about so let's do triangle BCA, congruent triangle. Like I went from B to C to A. There's 1 arc, 2 arcs, 3 arcs, but in the same order. 1 arc, 2 arcs, 3 arcs. Triangle BF. Okay, so let's look at some examples. So most of what we're going to do today is, and pretty much all of your homework is just proofs, but I think it's just drag and drop. Okay? So for the we do, this is going to have 2 steps to it. Statement. Actually, let's look at 3 steps. Statements, reasons. Let's set up your 2A part. All right, we're not going to bother with like givens here. I mean, we could if we wanted to say that, you know, we'll see some example W side T is convert to WB, but let's just skip those steps. We want to prove that UB is congruent to XB. So UB, this side is congruent to this side. So can I prove that the triangles are congruent right now? I maybe say something first. Martin. Yeah. Let's go ahead and mention that the vertical angles are congruent. So let's do TVU. Well, TVU is congruent to angle WBX. And that's because it's vertical angle congruency. And then now we can see that the triangles are congruent. And really we can just say it in the same way that we said these angles. So we can say triangle TVU is congruent to triangle W, oh, I put a double up there, WBX. Which triangle congruency theorem shortcut should we use? know the triangles are congruent, we can prove that any of the corresponding parts are congruent, which is what we are trying to prove. We're trying to prove that UV and XV are the same. So now we can do that in step 3. So notice we first prove the triangles are congruent, then we can say that the corresponding part is not. So let's put what we're trying to prove, UV congruent to XV. And then for the reason, we would just simply say corresponding parts of congruent angles are congruent. Feel free to write it all out or use the abbreviation. Okay, so look at the we do or the action. We'll do the next one, and then I'll let you try the you. For the you do, there's only 2 steps to it because you're working ahead. You only need 2 steps for that one. All right, so this one is actually only going to have 2 steps as well because we don't need to say anything else before we say that the triangles are congruent. So I'll just put S for statements and R for reasons. For the sake of being based on word. And number 1. Can we say right now that the triangles are congruent? Right away. We have nothing yet. By what theorem? Yeah, side angle side. So the reason will be side angle side. Because the angle J and M are in between the 2 sides. And we'll just say, how about K, J, L, and then N, M. So triangle K, J, L, congruent to the triangle N, M, L. Now that we know the triangles are congruent, we can prove that angle JLK, so this angle, we have 2 arcs, 1 arc is already taken, and we're going to have an outline. And be careful because these aren't vertical angles. Some people might look at that and maybe think that they're vertical angles, but they're not, because they're not like opposite. This is like that, that would be like that. This would be the vertical angle. So you wouldn't use like vertical angles. Anyways, I'll say what we're going to prove. J, L, K, and CPCTC. Alright, go ahead and try the we do. Pretty sure you only need, oh yeah, like what I said, you only need 2 steps for that. Remember, side angle is not we have right triangles. Okay, so I said that the 2 triangles are congruent. It doesn't matter what order you pick. I just did STR congruent to RVB. So in order to check, what I do when I'm grading yours, if you're doing this, is I check to make sure that your letters are in the same order as mine. So if you said, like for example, STR, that'd be the, oh wait, no I didn't, that's what I said. SRT, S and then R and then T, then you should have RUB. So that's from hypotenuse legs, these are right triangles. sorry, I'm getting mixed up. R, S, R, T. No, you have to do R because this angle and that angle match up. So you have to do R, U, V. Yeah, there's like so many ways you can rearrange these letters. Just make sure that they're right. R, okay, if you did R, T, S, then you have to do U, V, R. You do that to the other one? Okay, then you're good. Okay, just now we have a basic application here. That explain how to use the measurements in the diagram to find the distance across the pond. So, do we know that these two triangles are congruent? Because at first I would say, oh, wait, these two should be kept. But do we know that these two triangles are the same? Yes, because you got 55 and 55, so that's the same. And then you have 68 and 58, that's the same. And then you have vertical angles. So by side equals side, we can say triangle of view A and B is congruent to the other one, which its corresponding parts are C and D. So C is in the middle. And then we can say by corresponding parts of congruent triangles are congruent, then AB would also be congruent to CD. And then since AB equals 57, BC also equals 57. So that's how I would explain it. So I basically just wrote kind of like a paragraph as my explanation. All right, and then to the next one. So we have two givens. We're going to put our givens on different lines. And it says, why are the triangles congruent? So with the givens, go ahead and mark everything in your diagram that you can. So if R is the midpoint of SI, then we can mark, okay, then we can mark SR congruent to RI. And also we know that angle S is congruent to angle I. We mark that congruent to I. We also have vertical angles, so you can mark congruent. So why are the two triangles congruent? Yes. Angle side. So let's go ahead and write down our two givens on the first two lines. R is its midpoint of SI. Angle S is congruent to angle I is given. All right, what could we say next in our proof? So we're going to try to prove that the triangles are congruent using ASA, but before we do that, we need to say what all of these things are. And then once we prove that they're congruent, we can use CPCTC to say that the other angles are congruent. I mean, yeah. Technically, I guess there are ways to prove that, but most can do it. Yeah, it's a vertical. So it will S R Q convert to I R. Okay, and then with the midpoint, remember how whenever we have given that something is a midpoint or something else, we can use what? I'm not sure that we need to use that one. But then remember, if you have something that's a midpoint, what are you going to use with that? Yes, we're going to use definition of the midpoint. So for the next step, you could say, by definition of the midpoint, exactly what we put in the diagram. SR, convert it to IR. And then now that we've proved those things that we marked in the diagram, we can say that the triangles are congruent by ASA, because it's already talked about. So we can say triangle SRQ converts to triangle IRH by just using kind of how we put it in the step 3. There are many different ways to put in the triangles, and that's ASA. Since the triangles are congruent, we can prove all of the parts are congruent. Now we can say congruent to angle H. Now, they did say at the top, the right proof to show corresponding parts are congruent. So we did use CPCTC, but was there an easier way to show that angle Q is congruent to angle H? Madison? Yeah, I guess okay, so what you would do for that is if you had angle S and R here, you can say that the HI is parallel to SR or SQ by the alternate theorem, the converse theorem, and then with that, you can also prove that those two angles are but there is an even easier way of doing that. How about the third angles theorem? Right? You're trying to prove that the third angles congruent. So you could have skipped step 3 and 5, or sorry, step 4 and 5 here to stay here. They wanted us to use these things. Okay, and is this on your rankings papers? No, okay, no, we're not. So, this might just be on the board, maybe not. So go ahead and try your homework. And make sure that when you are doing the groups, you're not just trying to fill in parts of it without reading the entire question. Make sure you really try to read it and understand the process that the group's going through and try to internalize what is going on. Rather than just like trying to do it as fast as possible. So ask yourself, if I were given nothing, how would I, like, if I were, or maybe if I weren't given options for a drag and drops, how would I write this?